Oops. Hello, pre-calc. So today we're going to talk a little bit more about the unit circle, but more specifically using the concepts from the unit circle to find other values with things called trig identities and cofunction identities. So in math, an identity is just something that we can take for certain. It's fact. So like 1 + 1 = 2. That's fact. All of the things that they're telling us, if you think back to when you were in geometry and you had to write proofs, we always needed to justify our reasoning of each line that we wrote down with a fact about math. It might be a theorem, it might be an axiom, it might be a postulate. We're going to do similar things here with these identities, and these we can prove some trig identities, and that gets a little complex. If we come back to school together, we'll do that together. It's a little too hard to do probably remotely, so we're just going to take some baby steps here, but I want to bring your attention to the trig reference sheet. If you haven't printed this off or saved this to your computer, I again attached it in the remote school day folder, so make sure you do that, okay? But if you look here, we have something called cofunction identities. So cofunctions, these are all your trig functions, are the ones that sound like they should go together with the word co. So for example, sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. So all of those things are the cofunctions that we're talking about here. And if you look here, it says the sine of pi over 2 minus theta should be equal to the cosine of theta. And we'll talk about why that works in a couple minutes here. But one thing I do want to make a note of is they're using pi over 2, but remember that's the same thing as 90 degrees. So if you're given something that says sine of 90 minus theta, that's exactly the same as pi over 2 minus theta. Okay, so cofunction identities is one place that we can go and look. And then down here there are all these different identities, and like I said, if we were actually in class, I would do a little bit more about where these actually come from. But for right now, I just want us to know that they're there. We're going to reference them. We can go back and look at them. Some of them you already know. Tangent, sine over cosine. We talked about it before as being y over x. Again, don't forget that we're not always going to be on the unit circle, and most of the time we won't even be using an actual angle here. But sine over cosine is probably the easiest way to remember that. And cotangent is the reciprocal of that, so cosine over sine, right? The only difference is they're flip-flopped for tangent and cotangent. All right, so then we get reciprocal identities. Again, a lot of these you already know. So cosecant is just 1 divided by sine. What we've been doing is taking the reciprocal of sine, but same idea. Secant is 1 over cosine. Cotangent is 1 over tangent, and vice versa. On the other side here, sine is 1 over cosecant, cosine is 1 over secant, tangent is 1 over cotangent. So we can keep using those reciprocal identities. Pythagorean identities, so if you haven't guessed, these all come from the Pythagorean theorem, right? So sine squared plus cosine squared is equal to 1. That's one of the things we know is fact, and again, this comes from your unit circle. I can show you how to prove that if and when we get back to school. Tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. And cosecant squared or secant squared works just like if you had an x squared, okay? Same idea. You could take the square root of it, but it really means that you have cosecant of theta times cosecant of theta. Oops. All right, so let's see first if we can use these thoughts, these cofunctions, to help us fill out this chart. So this is the first thing you guys are going to do in your assignment too. So if you want to start filling this out now, it's not a bad idea. So 17, it gives me the sine, and it wants to know that value for 30 degrees. Well, first it wants to know what is 30 degrees in radians, and that is pi over 6. Remember, if you're not sure, you're multiplying by pi over 180 to convert, and that would give us pi over 6. And now think about your unit circle. What is the sine of pi over 6, or the sine of 30 degrees? Well, if I look here, 30 degrees is right here. The sine is 1/2. So sine, the function value will be 1/2. All right. Now let's look at cosine. Cosine for 45 degrees, that's going to be pi over 4. Well, we know if we go to 45 degrees or pi over 4 on our unit circle, the cosine is the square root of 2 over 2. All right, then we're going to find tangent. This time they gave me the radian, so pi over 3. We know pi over 3 is 60 degrees. And I should mention they're telling you to keep all your angles between 0 and 90, so we're just sticking to first quadrant values. And remember, tangent we find by doing sine over cosine. And I'm going to let you guys figure this one out. I'm not going to do them all for you. But let's look at one of the ones where they give me the function value. So here, let's do 22. They said we're using the function cosecant, and we know that cosecant is 1 over the sine, or 1 over y. And this angle has to be between 0 and 90, and we have to figure out what's the angle, right? So for cosecant, we have to think, okay, which sine value can be reciprocated to give me the square root of 2 as an answer, all right? So I'm going to go back to my unit circle for a second. And if we look at this unit circle here, just in the first quadrant, well, if I reciprocate the square root of 3 over 2, that's not going to give me the square root of 2. Neither will 1/2. But the square root of 2 over 2, I bet, will give me the, oops, I'm looking at the wrong value. We just want the y value here. So square root of 2 over 2, if I reciprocate that, I bet that's going to give me the square root of 2. So I think 45 degrees and pi over 4 are what I want, but let's go and check. So if I do, 1 divided by the square root of 2 over 2, that's 1 times 2 over the square root of 2, which is 2 over the square root of 2. And if I rationalize that, I get 2 square roots of 2 over 2. 2's cancel, and I just get the square root of 2. So that was the right angle. So I want 45 degrees, or pi over 4, okay? And so the hope is the more that you do this, the faster you will get, because you can start to remember, okay, which angle gives me the square root of 3 over 2 as a sine? Which angle gives me 1/2 as a cosine, etc. So see if you can finish that chart, again, using some of these identities to help you out when you get to points like that. And then I'm going to give you a few other problems to try. And we still want to use all these identities that they're talking about. So let's look at 27 here, all right? So they're telling me, this is what I'm given. Again, think about this in terms of a proof. I'm given the sine of 60 and the cosine of 60. The sine of 60 is the square root of 3 over 2, and the cosine of 60 is 1/2. So the first thing they want me to find is the tangent of 60. So if I'm going to find the tangent of 60, well, I know from my trig identities that the tangent is equal to the sine divided by the cosine. And whatever angle they're asking for, you're going to want to use the same angle here when you calculate this, all right? So in this case, we get the square root of 3 over 2 divided by 1/2. In a double stacked fraction, those denominators cancel, so we just get the square root of 3. So tangent of 60 is the square root of 3. Hopefully everyone's okay with that. But then the next question they ask me is, what is the sine of 30? Well, they didn't give us a 30-degree angle, right? And again, pretend that we don't know anything about the unit circle right now. I just want to think about this in terms of our trig identities. So the sine of 30, but I do know that sine and cosine are co-functions, right? So if we think about co-functions, that means that we have to use, if we look at our cofunction identities, all the way up here, our cofunction identities here, we're looking for the values that are complementary, because here I'm saying they have to add to 90, right? So if we know the sine of 90 minus theta is equal to cosine. And we also know that the cosine of 90 minus theta is equal to sine. So those are trig identities I'm going to sort of bring down with me in my head. So the sine, I'm using 90 instead of pi over 2 because we're dealing with degrees here. So we know the sine of 90 minus theta is equal to the cosine of theta. And we also know that the cosine of 90 minus theta is equal to the sine of theta. So watch what happens here if I use these two identities. Again, these are math facts. Well, 90 minus theta, that means that the angle is complementary, right? So I have a complementary angle, and complementary angle is anything that adds up to 90. So if I want to find the sine of 30, so if I make this sine of 30, then on the other side, I have to have the cosine of 90 minus 30. And the cosine of 90 minus 30 is 60. So what we know is that the cosine of 60 is the same thing as the sine of 30, right? Now, I want you to think about why that's actually true for a minute. Think about those angles. If I put them in a right triangle, you would have a 30, 60, 90 right triangle. So depending on which angle you start from, the opposite and the adjacent are going to swap places, right? Let's think about that. Here's my 30-degree angle, 90 is 60. So if I want the, we'll call this A, B, and C. If I want the sine of 30, well, it's going to be the opposite, which is A, over the hypotenuse, which is C, right? All right, so let's change that and look for the cosine of 60. Cosine is adjacent over hypotenuse. Well, this time the adjacent side happens to be A, and the hypotenuse happens to be C, right? So co-functions of complementary angles are equal. Co-functions of complementary angles Miss M likes to say that they're congruent because it rhymes. Co-functions of complementary angles are congruent, or it doesn't rhyme, but it's alliterative. But that's not actually true, so we'll use the right word, equal, okay? So all I have to do, once I know this information here, the cosine of 60 is the same as the sine of 30, well, I can say the sine of 30 then is equal to 1/2. Didn't have to do any math there, just had to look, right? So similarly, the cosine of 30 has to be the same as the sine of 60. These are complementary angles, and sine and cosine are co-functions. So square root of 3 over 2 is the cosine of 30. And then cotangent of 60 would just be the reciprocal of tangent of 60. So it's 1 over the square root of 3, or square root of 3 over 3. Right. Let's do one more together just to make sure you got the hang of it. But remember, keep going back to those trig identities that we're going to be using here. Let me get rid of all this. I think there's a faster way, probably. Still learning my technology. Oops. There we go. All right, let's try 30 here. So here they're saying the secant is equal to 5, and the tangent is equal to 2 square roots of 6. And the first thing they want me to find is the cosine of theta. Well, remember, cosine is the same as 1 over the secant of theta. If we, again, look at our, sorry if I'm making you nauseous, if we look at our reciprocal identities, the cosine is equal to 1 over the secant of theta, right? So, when I am trying to find the cosine here, we can just do 1 over, and they gave me 5 as the secant, so it's 1/5. All right, cotangent of theta, well, that should be the reciprocal of the tangent of theta. So the cotangent is 1 over tangent, or 1 over 2 square roots of 6. And if we rationalize that, multiply by square root of 6 over square root of 6, we get the square root of 6 over 12. So that's what the cotangent would be for part B. Let's see. Then it says C is cotangent of 90 minus theta. All right. So if the tangent of theta, if we know the tangent of theta, then we know the cotangent of 90 minus theta, because these two are cofunctions and these angles are complementary. So the tangent of theta is equal to the cotangent of 90 minus theta. That's the definition. So it's just 2 square roots of 6. And then the tricky one is sine, right? So a couple ways you can get that. There are 2 trig identities that could help us. One is that, oh, that was funny, sine squared plus cosine squared is equal to 1, right? That's one of our trig identities that has the sine that we're looking for, and we already have cosine, so we can use that. And the other thing we know is that tangent of theta is sine divided by cosine, right? And we have cosine and we have the tangent, but we don't have sine. So if I did the first option, option A, we'll call it, sine squared, we don't know, so sine squared, I'm going to leave, plus cosine squared, well, cosine is 1/5, is equal to 1. So sine squared plus 1/25 is equal to 1. 1 is equal to 25 25ths. So if I take away one of those, then we get sine squared is equal to 24 over 25. And then we can take the square root to find sine. So it's the square root of 24 over the square root of 25, which is 2 square roots of 6 over 5. All right, so that's one option. Option B is to use the tangent is equal to sine over cosine trig identity. And I'm using this because we have 2 of the missing pieces. The only thing we don't have is sine. So I'm allowed to use this. That will help me find the piece that I'm missing. Well, I know tangent is 2 square roots of 6. Sine is, we'll call it x for now. And cosine is 1/5, right? So again, if I have a fraction divided by a fraction, I'm going to multiply by the reciprocal. So this is really 2 square roots of 6 equals 5x. You can put it over 1, but you don't really have to. And then divide by 5, and we get 2 square roots of 6 over 5. Same thing, no matter which way you do it. We just had to use a different trig identity. All right, so I'm going to stop there. Go ahead.